Okay, so we're going to be looking at three different continuous random variables: normal random variable, and F distribution, and exponential distribution. So let's start with the normal distribution. The PDF function, probability density function for normal distribution, is this, and when you plot and the possible range of values for x is minus infinity to plus infinity, so the entire number line. And if you insert various values for x, and when you plot f of x, so y-axis is f of x, so this is the curve that you will see, the normal distribution curve. And there are several properties that are apparent. One is it is symmetric around the center. Okay. And the center is going to be the mean of the probability distribution. That's called mu. Mu represents population mean. Okay. And what you see on the left is a mirror image of what you see on the right. So symmetric distribution. Okay. And another property of a normal distribution is that, generally speaking, if you look at an interval of one standard deviation, so here sigma is standard deviation, so if you go one standard deviation to the left and one standard deviation to the right, and that probability will be roughly about 70%, little less than 70%. And if you go two standard deviations on either side, okay, that will be slightly over 95%. And three standard deviation interval, okay, to the left and to the right, will cover almost all, 99.73% of all the values in the normal distribution. So that's the reason why often plus or minus 3 standard deviation is used as a kind of a quick and dirty way of computing all reasonable values for a given process. Okay. Now, how does this, there are two parameters for normal distribution. Mu is the mean and sigma is the standard deviation. Okay, two, mu and sigma, right? And there is one more property of normal distribution. Because it is symmetric, the mean, the median, and mode, they all fall exactly at the center, the same value. The mean is the median is the mode, equal to mu for normal distribution process. Okay. Now, the mean and standard deviation, mu and sigma, when that changes, what kind of different probability density function graph you are likely to see? Okay, so here are some examples. Okay, so here is mean of 0, right? Okay, if the mean is -2, so that's your green, so -2, so shifts to the left. So mean is greater than 0, then the curve will shift to the right. Okay, that's obvious. Now what about the variance or standard deviation sigma or variance sigma squared? Now the variance directly represents how flat or how peaked the distribution is. So smaller the value of the variance, more peaked the distribution will be. Okay. Larger the value of the variance, more spread out. Okay, like for example here if you see sigma squared is 5, so you see really flat, covers a lot of area. Okay. And sigma of 1, okay, so that's your red line. Okay. So standard deviation directly indicates how flat or how peaked the normal distribution will be. The mu value is the central value. So mu can be any number, positive or negative, and sigma has to be positive because it is a positive square root of variance. Variance is positive, So standard deviation is positive. Okay. Now, there is one specific normal distribution that has a special function, and that is called standard normal distribution. Okay. And standard normal distribution is a normal distribution for which the mean is 0 and the standard deviation is 1. Okay. A normal distribution with mean of 0 and sigma of 1 is called standard normal distribution. And the reason for standard normal distribution's importance is that all normal distributions can be converted to an equivalent area in the standard normal. So if X is any normal distribution, if you subtract its mean from X and divide by its standard deviation, this mean mu is the mean of X, this standard deviation is the standard deviation of X, so X minus mu over sigma will follow standard normal distribution, mean equal to 0 and standard deviation equal to 1. And therefore that allows us to tabulate normal distribution areas for just the standard normal curve. So here is the standard normal curve. So here is the standard normal curve. So we have the areas tabulated. Okay. So at the mean, the z value, we use the notation z for standard normal. Z is 0, the probability will be 0.5 because the entire area is 1. So 1/2 is 0.5, the other half is also 0.5. So you start with 0.5 and then it builds. Okay, so you have a table. So what this means is that if you want probability of any normal distribution, okay, for some range, we want probability that X is between 10 and 15, when mean is 5 and standard deviation is 3 or something. Then you can convert that into a standard normal equivalent and then look up the area from the standard normal table, and the probability that you get from the standard normal table will be the probability for the original normal distribution that you started out with.